Hello, welcome back, welcome to everybody. In this new video I would like to tell you something about a very exciting project I have been working on in the past years, which is an FM tuner with vacuum tubes output stage. As I think it came out pretty well, it sounds very good, in my opinion, of course. Yeah, I think it's worth dedicating a video to that. I hope you enjoyed the video and thank you very much for your attention. In this first picture you can see how the FM tuner is looking like. From left to right we find the so-called, I have called that way, super fidelity switch, which engaged selects a very wide IF filtering, which is implemented by LC filter. In this case, one of the two LED you see in the middle lights up. The other position of this switch selects a little bit narrower IF filtering, which is implemented by ceramic filters. Then we have the stereo mono switch, again with the relevant LED on the right. Then going to the center, we find the two meters on top. So the first meter is the usual S meter, which shows the strength of the received signal. Going a little bit on the right, we find also the tuning meter, which shows if the station is properly tuned or not. Below you can find the frequency counter, and on the right you can find the tuning knob. I think the main highlight of my project is the vacuum tubes output stage, which you can see in this picture. You can see the two 12 SN7 vacuum tubes, which are installed in cathode follower configuration in order to achieve a very low output impedance and, first of all, very good sound, in my opinion. In this picture you can see how the FM tuner is arranged internally. Let's follow the signal path. So the signal captured by the antenna is fed into the front end, which you see here. As you can see, the front end is a 4-gang front end. So we have 3 antenna filtering stages and 1 local oscillator. The role of the front end is to convert the incoming radio signal into an intermediate radio signal, the frequency being 10.7 MHz. Then the signal captured at the output of the front end is fed into the intermediate frequency stage. As you remember, we have basically 2 intermediate frequency stages. One is the LC filters based intermediate frequency stage, which basically provides the super fidelity path, and then we have another filtering stage, so another intermediate frequency stage, which is based on ceramic filters, and this provides the, I would say, normal fidelity position. After the intermediate frequency stages, the signal, still a radio signal, the frequency being 10.7 MHz, goes to the input of the audio demodulator. This stage is based on an LA1235 integrated circuit. At the output of this stage, the signal, I have my audio demodulated signal, which is then fed at the input of the stereo decoder. Then, at the output of my stereo decoder, the signal is then fed to the vacuum tubes output stage, which you can see on top right of this picture. Very important for sake of audio quality and signal to noise ratio, the power supply module, the power supply boards. So we have the power transformer This was built according to my specifications. Then we have the different boards which provide the different voltages to the various sections of the FM tuner. For example, the high voltage for the vacuum tubes, the 12 volt stabilized for the for several sections of the FM tuner, and so on. And also, for example, 5 volt for the frequency counter. Just one final mention about the frequency counter. This is a tiny board you might see here. The RF signal for the frequency counter is picked up from the local oscillator coil within the front end. Still speaking about the layout, you can see the star grounding point. You can see it on top left of this picture. According to my experience, this is the most effective solution against noise. In fact, as you see, I extensively utilized this layout. As you can see, each and every grounding cable, grounding connection coming from all over the circuit is terminated into this central grounding point. I would like to show you in more detail the audio demodulator and stereo decoder stages. As you can see, the audio demodulator, you can see it on the left, is based on the LA1235 integrated circuit. This is really one of the best integrated circuits available. So maybe now it's no more available. It was anyway top of the line, I would say, in the 80s. So the signal coming, the radio signal, 10.7 megahertz, coming from the IF intermediate frequency stages, is fed into the input of this demodulator integrated circuit. At the output, I have my audio signal, which is then fed at the input of the stereo decoder integrated circuit. You can see it on the right. This is based on the LA3450 integrated circuit. Again, also in this case, I have chosen what I think is the best integrated circuit available, which was implemented in many of the higher end tuners in the past. At the output, you can see those very nice paper in oil green capacitors. At the output, I have my 2 channels. I have my stereo signal, which is then fed into the vacuum tube's output stage.
On a Monday, can't tell me.